Hello guys. So today we'll be discussing about a new topic that is called ring expansion. One of my students asked me this. I promised that I will answer this question, but it will take around an hour of class. And frankly speaking, I wanted to answer that day only, but the thing is I couldn't do that. One thing was a problem of time, and another thing was I did not want to do something that I will say you something and you will just understand or you don't understand. It really matters to me whether you understand it or don't understand it. Because the thing is that while we are talking about ring expansion in a cycloalkanes, you have to know about cycloalkanes. Now, you haven't been taught cycloalkanes in your school, you haven't been taught cycloalkanes in your textbook, and suddenly you will come up with an idea or come up with something that is quite Hebrew to you, or even Hebrew to me also when I was of your age. Okay, so everything needs some base behind that one. So I tried to conglomerate this ring expansion thing with the concepts that we have already learned in chemical bonding. So basically I tried to make things understandable. So let us see if we can understand it in a much shorter time, because we are not going into cycloalkanes at this moment. We are just going to study ring expansion, but we are going to understand it, what is the theory behind it, how this thing is happening. So from the things that we have already learned, I do not want to do things that we have not learned or we are not going to learn at all. So let's do it from what we have learned. Okay. I wanted to do this earlier, but I'm sorry, this week one of my relative expired, so I didn't find any time. This is the first day I'm finding time at this moment at 11 o'clock. Today also I am coming from that relative's home. So anyway, let's start this. We will talk about ring expansion. So first of all, we do not know much about cycloalkanes. So let us just have a little bit of idea about the cycloalkanes part. So if you see a cycloalkane, let's take this one. This is basically propane, cyclopropane, and let's take this one. This is basically cyclobutane. So you already know these things. Now, what is the difference between these two with respect to chemical bonding? Well, you can say that the main difference that I can see over here is that there are 3 chemical bonds over here, 3 covalent bonds, here there are 4 covalent bonds. But another thing is there, if you see the bond angle over here, it is 60 degree. While over here it is 90 degree. Okay. So now I just want you to go back with your mind back to the chemical bonding chapter where you have learned about bond pair repulsion, and lone pair repulsion, all those things. So I think you are remembering something at this moment. So if there is more amount of repulsion, there will be more instability to the molecule. So if you see this molecule, this is basically having 60 degree angle. So there are 2 bond pairs over here, this one and this one, there are 2 bond pairs. So in these 2 bond pairs, there will be much more repulsion than in case of cyclobutane. So wherever there will be more repulsion, there will be some strain in the bonds. Okay. So that strain basically is much more in case of cyclopropane than in case of cyclobutane. So cyclobutane will be much more stable than cyclopropane. Now if I go for cyclopentane, it will be much more stable with around 108 degree angle. I am going for cyclohexane, 120 degree, much more angle. So it will be, stability will increase because the repulsion is decreasing as the angle is increasing. If the angle is increasing, the bond pairs are going away and the repulsion between the bond pairs are decreasing. So up to n is equal to 6, the bond angle decreases. So up to n is equal to 6, the bond angle decreases and stability increases as bond pair repulsion is decreasing. So please note down all these things that I have spoken. If you can pause the video. Okay. So now coming back to the subject matter. this is very important actually. Without this, I myself cannot understand what is ring expansion. So that is why I revised all these things for you. So now let us take a cycloalkane like this. So I can write this cycloalkane as this. This is methyl butane. So if I move one proton, then what does it become? It becomes a carbocation having a positive charge over here. Now if you see, this is basically a 1 degree carbocation. So as you know, 1 degree carbocation is not very stable. So what happens over here is, this bond tends to break. So if this bond breaks, so I'll just do it over here. If this bond breaks, this electron pair over here shifts to this carbon. अभी पूछो सर, ये carbon पे क्यों नहीं गया? It could have gone to this carbon also, but I'll just come to it. First you see why it has gone to this carbon. So as this has broken up, now the structure is like this. This is negative charge and this is positive charge. So the electron pair has gone to this carbon, so this is having the negative charge. Now this negative charge will attract this one and this will come here and join, and we will get this compound. So see, this is negative charge, so this will join with this carbon. This carbon is coming over here with its 2 hydrogen, and obviously this is already joined with this, and the positive charge remains over here. Now if you see this positive charge, so the molecule is having this positive charge which is still positive at this moment. This positive charge is 2 degree, much more stable. So see, in the name of ring expansion, we are generally frightened that what is it extra? This is nothing extra. This is all about 2 degree carbocation is more stable than your 1 degree carbocation. There was nothing extra in it. This was simple philosophy, simple concept. Just the name is difficult. The name makes us think it a much more bigger thing than what it actually is. So you need not worry about all these things. Okay? So for normal NEET examinations, these are not required. This kind of questions, maybe 1 or 2 will be asked, and mostly in IITs these are very important. So you go through it as you have asked. I have gone through it with the concepts of chemical bonding. Nothing Hebrew about it. You already knew that if the bond angle increases, the stability will increase. Okay. So this is about the ring expansion that I wanted to talk to you about. I hope that this is clear to you. Now only one thing that I want to reiterate over here. Suppose if this bond was CH3, then this would have been CH3, then this would have been CH3. Now there would have been another step. See, this is 2 degree carbocation. Now if the positive charge lied on this one, it would have been 3 degree carbocation. Now this has a hydrogen. This hydrogen can shift over here via hydride shift, and we can get this compound actually. Sorry. So unsymmetrical one here. So this hydrogen is shifting over here, and here in this carbon there is one CH3, and I am getting the carbocation over here. So here it is 1, 2, 3. So 3 degree carbocation. Again, simple concept, nothing difficult. Hopefully you have understood this thing very well. So thank you.